JAGZ Cost Consultants, Building the Future. Hi there, I'm Ashalva Naidu, the CEO of JAGZ Cost Consultants, and today I have the pleasure of going through critical evaluations of a civil engineering bill. The evaluation will be done based on the SANS 1200G document. Before we get started on the critical evaluation, I'd like to run through a brief introduction on the project itself. Because of copyright and client confidentiality issues, the company of which we have sourced our bill has asked for the name and their client's name to not be disclosed. The case study that will be analyzed in this report will be the Civil Engineering Works Bill of Quantities executed by an engineering company based in Durban. The project deals with the construction of a community hall in Nkopo, KwaZulu-Natal. The site is a small town known as Ikopo, which is situated off the Nkomazi River along the R56 highway in the Midlands of KwaZulu-Natal. The site is situated just off the R56 on an unnamed road, which is surrounded by a church, sports ground and houses. Therefore, there is only one access point to the site. The scope of works for this project was split up into three portions. Portion 1 covers the earthworks for the project, Portion 2 covers the construction of reinforced concrete and the erection of structural steel portal frames, and finally, Portion 3 covers all masonry and external works. For the purpose of this assignment, the works done in Portion 2 will be our main focus. Now we will move on to the critical evaluation of the Bill of Quantities for civil engineering works. For the purpose of this assignment, we have used two bills, one bill being the main bill for the Ikopo Hall and another bill just to demonstrate further understanding of the concrete works in civil engineering. For this assignment, we have used two SANS documents, SANS G, Structural Concrete, and SANS GB, Concrete for Ordinary Buildings. SANS G provides a specification concerning the standards of concrete works. The specification details all elements to be taken into consideration when performing work concerning formwork, concrete, reinforcement, and other sundries with regard to concrete work for any project. The first case study only makes use of some of the clauses, but more clauses can be found in the second case study. For SANS 1200 GB, it covers all the same specifications as well as SANS 1200G, but for ordinary buildings with a floor area of up to 2,000 square meters. Now we'll move on to some examples of the evaluation. Subsection 8.2.1 Formwork. SANS 1200 GB provides a specification for each type of formwork, namely rough, normal, special, which is categorized into three groups with meters squared as a unit of measurement. Moreover, it states that the position or the element in the work shall be stated for each quality of finish. Concerning the normal and special finishes, separate items will be scheduled according to their different angles of inclination of formwork. The specification provided in the BOQ fails to categorize the measurement into one of the three categories, namely rough, normal, or special. The definition provides the inclination of the formwork as well as the quality of the finish, which is smooth, as per SANS requirement. The correct unit of measure was used, meters squared. Other than that, this item has been measured in accordance to the SANS document. Subsection 8.2.4 Reinforcement. SANS 1200 GB categorizes reinforcement into three main groups, namely steel bars, steel sections, and high tensile welded mesh. The unit of measurement for this section is in tons. The type of steel as well as the diameter shall be stated in the description of the item. Similarly, items under subsection B shall have their size stated. The mass of square and round steel bars shall have a diameter and be measured separately. No allowance shall be made for cutting waste, base devices, or binding wire. Concerning high tensile welded mesh, the reference shall be stated in the definition. Area should correspond with the one available on drawings, with no allowances again being made for cutting waste, laps, or deductions for end covers. The comparison for case study 1. The correct annotation was used in the definition. The steel reinforcement in the description to be found in their foundations and beams, and both high tensile and mild tensile steel are used, with the correct unit of measurement. Since 8.2.10 in the last clause of SANS 1200 GB, it was assumed that due to its use, the steel reinforcement in the foundations and beams, as well as high tensile welded mesh found in the surface bed were measured under SANS 1200G structural concrete. The high tensile welded mesh provided the reference as well as the location and the use of the correct unit of measurement in tons. Subsection 8.2.5.1b Strength concrete. This section states that the grade and elements to be cast in the work should be stated. The type of cement to be used shall be stated, except in the case where the normal Portland cement is specified. The unit of measurement is cubic meters. The grade and strength of the concrete is clearly provided in our case study, and it is stated as grade 30 MPa by 19 mm concrete. The position or element to be casted is specified. The concrete casting is to floor slabs and beams. The unit of measurement was cubic meters, and therefore the section in our case study has correctly measured in accordance to SANS 1200 GB. Subsection 8.2.6 Unformed concrete surface finishes. SANS 1200 GB categorizes unformed concrete surface finishes into four main sections, namely wood floated finishes, steel floated finishes, power floated finishes, and other special types of finishes. This section is linked to clause 5.3.10.1, which specifies that exposed surfaces of concrete not finished against forms shall be brought up to level with suitable screed boards. The unit of measurement is meters squared. The definition in the SANS document requires where the instance the type of finish is described with the area or element it is being applied to. This has been measured in accordance to SANS 1200 GB for our case study. Subsection 8.2.8 Joints. The joints description includes movement joints and any other designated joints. The unit of measurement is meters. Only designated joints shall be measured as described in clause 2.3.3 in the SANS 1200 GB. The length shall be the length as specified on the drawing. In comparison to case study 1, joints have been measured in accordance to the SANS requirement, and the unit of measurement is in meters as specified. Clause 8.2.10 Provide HT bolts and miscellaneous metalwork. The unit of measurement advised by the SANS document is in tons. The method of procurement of the bolts shall be stated. Separate items scheduled as specified in 8.2.9b. This has been measured in accordance to the SANS document. SANS 1200G. Subsection 8.2.9a. Grouting under bases or plates. Clause 8.2.9a specifies that grouting filled under structural steel column bases or members or under pumps shall be measured by the volume of grout that is needed to fill the void between the underside of the metalwork and the surface of the concrete. No deductions shall be allowed for bolts, packers, and base plate shear keys that are protruding into the grout space. The unit of measurement is cubic meters. For here, any work required shall be measured in accordance to subclause 8.2.1. In the case study, grouting to the underside of the base plate is measured in volume and no deductions are made for bolts and packers. Bolts here are measured as a separate item. The thickness of the grout is 25 mm and the item is measured in volume. Therefore, the item is measured in accordance to the SANS document. In conclusion, there were very few discrepancies within the bill, and most of the items measured were in accordance to the SANS 1200G and 1200GB documents. Thank you for your time. JAGZ, building the future.